When I mention the word laser, you might think of your laser pointer and you think of this nice circular beam which goes in a certain direction. But lasers are essential in our daily lives. In fact, they come in many shapes and forms. Some of them are extremely large and bulky, and some of them are very small. For example, there are lasers which are used in welding and cutting. There are other lasers which are used for data communication through the internet. And also there are lasers used for medical purposes like eye surgery. Also, lasers come in different flavors. Some of them are continuous, which like your laser pointer. Some of them come in pulses. Some lasers emit pulses as short as 1 over a billion over another billion of a second. Now, for when we think about a certain type of laser, one of the most important types is the semiconductor laser. The semiconductor laser is not the most powerful laser. It doesn't emit high power, but it is very small and it is essential for applications in datacom and in data transmission, which actually is the backbone of our current internet technology. These semiconductor lasers are made mainly from some materials called 3,5 materials, like gallium arsenide, for example. These materials are excellent materials. They have been under development and are very mature for more than 50 years, but there is a catch. Now we are witnessing a new revolution of photonic applications and chips, which require higher density of lasers than was ever seen before. So for these kind of applications, 3,5 materials has the problem that they are not easily integrated on silicon chips. Other materials, like perovskites, can be integrated virtually on any different type of substrate. You can put them on plastic, you can put them on glass, you can put them on silicon, or on any different substrate you might think of. If a perovskite is used in a laser diode successfully, that can enable a new wave of applications that can span many different applications, including in quantum applications, in photonic integrated circuits, LiDARs, and beyond. One of the biggest issues of perovskites is that they have low thermal conductivity. And for lasers, you need to inject a lot of current. This current injection leads to a lot of heat accumulation, which can destroy the device. So one of the biggest issues that needs to be dealt with, how to effectively manage the heat accumulation inside the device. Also, environmental instability is important. Perovskites are sensitive to humidity and oxygen, but this can, for example, be circumvented by proper encapsulation. This project combines expertise from some of the top research groups in Europe, spanning expertise in theoretical calculation to material synthesis to device integration. By combining their efforts, they hope to achieve the elusive goal of perovskite laser diode, which would eventually change the landscape of many applications around the world.